Hey folks, Mr. Dell here. We are looking at box plots. We're actually taking two sets of data and doing a parallel box plot to compare weights of these subspecies of birds. So we're digging this from CPM is where we're taking this problem from, and it's CC2. It's our course 2, and this is section 8.3.2, number 877. So let's read it, and we'll go from there. Scientists studying prehistoric birds have estimated the weights in grams of two different subspecies of birds. The data they collected is shown below. So we have these pre-emergent thrushes. That's their weights in grams, and then these post-emergent thrushes, these are their weights in grams. So it wants me to create a parallel box plot to compare the weights of these two subspecies of birds. Remember, in order to create a box plot, you've got to first get all of the numbers in order, right? Because there's five components to a box plot, right? So when you do a box plot, you need 5 pieces of data, right? You need the median, okay? You need the lower quartile. You need the upper quartile. And then you need the range, basically your lowest and highest piece of data. Your lowest number and your highest number. Okay, so those are the 5 pieces of data that you need in order for a box plot. So, but in order to get all of these, we have to take our data and put it in order. So let's start with pre-emergent thrushes, and we'll put that in order, right? So we have, let's start with the smallest, looks like 49. And I'm going to cross off as I go. Then looks like 52, then 54, then looks like 58. And I'm in the 60s now, so I've got 61 and 61, two 61s. And then I've got a 67 and a 68. I'm in the 70s. I look like I have a 72. And then I have 3 73s. 73, 73, 73. Oh, I'm going to run out of room here. And then I've got a 78. Uh-oh, I'm going to have to take my data up this way. 78, and the next one after that is the 82, then 83. 82, and 83. There we go. Sorry about that, but there's our data in order. So from there, now we look for the middle, right? The median. The median is the middle. That is the middle number once the data is in consecutive order. So remember, to find the middle, you're going to count in. So I'll go 49 in, and count your way into the middle. So it looks like my very middle is 68. So that's my median. Okay, so I'm going to create my first box plot. Then I will line up my second one based on my scale. So 68. So I'm going to just, I like to label what I have. So I know I've got the middle of the box is going to be 68. That's my median. Then I look for my lower and upper quartile. Remember, lower quartile is the middle of the lower half of the data. So there's my medium, the lower half. So we'll work our way in there. 1 in, 2 in. Looks like right there, that's my LQ, my lower half. So that's at 58. So I'll go to here and call that 58. The upper half is the upper quartile. So again, work our way in, and we're looking at, this is, let's go this. We're going to go Let's see, they got 2 in, and then there we go at 73. So 73 is my upper quartile. So let's see, if that was a 10, and this is where you got to get your scaling, right? So this is 58. I'm going to go, I've got a 73, so not quite. That was, if I have that as being my 10, I'm going to go up to 73, which is not fully 10, only 5 up. No, 6. Yeah, no, 5 up. Yeah. So I'll do half, 73. And then my lowest, now I do my whiskers, if you will, on my box plot. My lowest data is 49. So 49, the distance here looks like 10, so I'm going to take that and just about the same, but a little bit less, 49. Then my highest data is 73, so I needed that distance of 10 again. Be right there. It's 83. So that's my box plot for the pre. So this is the pre-emergent thrushes. I'll just label it pre for right now. And now let's do the post-emergent thrushes. So that set of data, we got to get that in order. Let's see, I'm going to put that, let me put that data, I still want it to be part of what I'm doing. I'll do a separate piece of paper here to get it on. There we go. So we're going to go lowest is, looks like 29. Then 35. 48. Okay, I think I'm in the 50s. I have a 58 and a 57, so we'll go 57, then 58. Now I'm in the 60s. I have a 65. The 60s, I have a 68. Okay, so 65, 68. Now I'm in the 70s. I have a 73, 74. Those are the two 70s. 73, 74. Now I'm in the 80s. I have 87, 85, and 88. So 85, 87, 88. And and I have an 86. Darn, I missed it. I didn't see the 86 there. So I'm going to squeeze him in. Make sure to remember he's in between there. Sometimes that happens. And then 91, 94, 97. 91, 94, and 97. 4, 197. Okay, so there's all of our data. So we'll work our way in. The middle, the other way to find the middle is just if you know how much data you have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 pieces of data. So I'm going to go 8 in, 1, 2, 3, 4, 5, 6, 7, 8. And this is also 8. So that means that right there is my median in this case. What is that number? Well, it's half of, it's in between 73 and 74. So the median is going to be 73.5. Okay, so I'm just going to get my pieces of data, then I'll transfer it over. So now we got to find the half of the bottom half of the data. And so there's 8 pieces. So I go up to 4, and I have 4 on one side, 4 on the other. So right between these two numbers is my lower quartile. And between 57 and 58 is 57.5. And then over here, upper quartile, I have 1, 2, 3, 4 in, 4 up. So again, right in there between 87 and 88, so that would be 87.5 is the upper quartile. Okay, and then you've got your lowest piece of data, your highest piece of data. So let's take that and draw a box plot based on that information, but I'm going to try to line it up. Right, so I want it to be on the same scale. It's a parallel box plot. So if I look at my median here is 73.5, well, that was my upper quartile. So I want this now to be my median at 73.5, just a little bit above. And then my lower quartile was 57.8.5. Well, this was 58, so 57.5 is just right below that. So that is my lower quartile, 57.5. My upper quartile is 87.5. So 87.5 is past my 83, but keep in mind, basically each of these distances were 10. So I just need to go another 5. So I'm going to go the full length here plus about half of that length, right? So almost that length there. So the full length plus half, so probably right about there to be at, line that up, 87.5. And then my upper data is at 97. That's about 10 away from 87. So I need that distance of 10 there. And then down here at 29, well, I've got to go almost 20, 30 away, really. Almost 30, because if I add 30 to 29, I would get 59. So just about 3 of those spaces, because I remember that space was just about 10. So 3 of these spaces. So there, 1, 2, 3. So that'd be 29. So right away, we can see that my data for my post, the data for my post-emergent rushes are really spread out in comparison to my pre, right? My pre, you can see that 50% of the weights of the pre are between 58 and 73, right? Remember with the box plot, you have it's a quartiles, right? So this is a fourth of the data, 1/4 of the data, 1/4 of the data, 1/4 of the data. So you look at it as half your data lives in this box. So I got half my data here, but it's a really spread out situation. So, all right, so there's my parallel box plots. So part A, we did that. So part B said, would the mean accurately represent the middle of the data? So I don't know, this is my median. I want to know if the mean would actually represent the middle of the data. And mean is not necessarily the middle, right? Median is the middle of the data. So mean is adding all the numbers up and dividing by the numbers of numbers. So sometimes it is, but sometimes it's not. And how you know really is the mean. If the mean is in the middle, you have equal, each quartile is the same. So my distance between here to here and here to here is not quite, it's close. So my median, my mean would be close, but it would not be the middle. How I know I would have the mean and the median be similar is if I have equal distance of data on either side. That would give it the closest accurate representation of mean and median. And again, here the same thing. I'm going to have my this data is way out here. If it was tucked in right here, it might be a little bit more probable that my mean and my median would be the same, that the mean could be the middle. So B, no, the mean would not accurately represent the middle. It's the median we would have to use for the middle of the data in this case. And then C, a fossil of a bird is found. Scientists estimate that its weight must have been around 75 grams. So which subspecies was the bird most likely a member of? So where is that 75 fall most likely? So if we look, remember up here, 75 is going to fall in here, and it could be there, but that's the least likely because it's going to be the top of the data. Down in here where we have 50% of the data sitting, it looks a little bit more likely that the 75 would land in this. So we were going to go ahead and say for that one, the post-emergent thrushes. So the fossil of the bird that's found is most likely in the post-emergent thrushes. So this set of data, the post-emergent thrushes. All right, there you go.